Some geology, plate tectonics. Really quick, Earth formed. It was a liquid molten Earth, and it cooled. Iron sank and silica rose. So the core is made out of iron and nickel. For the core, we have a solid core made out of iron and nickel. Then we have the outer core, which is the liquid portion of the core. And then we have a bunch of molten rock, which is the mantle. Then we have the outer crust, where we are. Let's take a look at the crust a little closer. Alrighty, so this is a close-up of the crust. We have the liquid mantle. Then we have the asthenosphere. This is the outer part of the mantle, and it is semi-molten rock. We then have the lithosphere, which is the upper portion of the mantle and the crust. This is about 100 kilometers thick. Which is about 60 miles. If you were to take a pie piece of the Earth from the lithosphere all the way down to the core, measuring from here to here, it essentially is going to cover the entire United States from coast to coast. In some places on the crust, we have areas that become thinner where the mantle actually reaches the top of the crust. These are called hot spots, and we'll take a look at what hot spots cause in just a little bit. So the lithosphere is made up of different plates, and those plates are in constant motion. They're just moving very slowly. Here is a map of the current position, or here is a map of the plates of the world. So the reason why the plates move is because of that hot mantle and the conduction process that's going on underneath the plates. So let's look at that closer. Okay. So let's say that this is the crust, the outer portion, this being an ocean plate, this being continental, land, this one also being continental. Here we have spreading motion, and this happens because of the conduction that's happening in the mantle. So the conduction happens as the center heat is heated, it's hot, and so heat rises, so that hot magma rises, and then it starts to spread out and cool. So then it starts to be pushed back down, and then as it's pushed back down towards the center, it's going to heat back up again. So we will see these conduction patterns in quite a few different places. We'll see this with ocean waters. We'll see this with atmosphere. Essentially, we have these, so we have this conduction that's happening in the mantle that's pushing these two plates apart. So that causes spreading of the ocean plates here. And because of that, these plates are going in this direction, and they are sliding underneath the continental plates. And as the continental plates are also moving, the continental plates are moving in this direction. So as this is happening, if the crust moves over a hot spot, that is going to cause essentially a volcano. So a volcano is a vent that is allowing that hot magma to come up. So when we have a volcanic eruption, that is when the magma is essentially flaring. That is when the magma is flaring and it's releasing gases, it's releasing the magma, and it's coming up through that hot spot. Once the plate has moved past that hot spot, you then get an extinct volcano. So the volcano is then no longer active. Let's look at a few different type of plate boundaries where two plates are coming together. We have a divergent plate boundary. This is where we have two oceanic plates that are being pushed apart because of mantle coming up in between them. So this is going to form new ocean crust. This is pushing up and out. And as this is pushing up and out, we are bringing copper, silver, and led to the surface. We have convergent boundaries. This is where one plate is sliding underneath another plate. So they're moving towards each other and colliding. And this causes an increase in pressure. And lastly, we have transform faults. And this is where when we have two plates that are sitting next to each other and they move in opposite directions from each other. So a fault line is a fracture in the rock, and there is movement here. When there is seismic activity, you have movement in these two plates as they're sliding past each other. And when there is a sudden shift in those two pieces of rock, that is when we have an earthquake. When you have high seismic activity, that's called a fault zone. And generally the fault zones are going to be areas of high earthquake occurrence. Mountain formation happens when you have two continental plates that are pushing into each other. And as they are pushing into each other, they kind of squish each other up, and you have mountains forming because of that. As we are looking at plates moving, plates move at about 36 millimeters per year. It's about the same rate as fingernail growth. So as we were talking with the transform fault lines, where the two rocks suddenly move and past each other and cause an earthquake. With earthquakes, we have the epicenter. The epicenter, it's a spot directly above where the rock ruptures. Let's take a look at the Ring of Fire. Here is a map. As you can see on the map, we have this ring of places where there are lots of volcanoes and seismic activity. It's called the Ring of Fire because that's where all of the volcanoes are and creating the fire from the mantle coming up through the crust. So along the Ring of Fire is quite a bit of seismic activity, quite a bit of earthquake, quite a bit of volcanic activity. And lastly, let's talk about the Richter scale. The Richter scale is a measure of ground movement during an earthquake. It is a logarithmic scale, meaning that each number on the Richter scale is a 10 times jump from the one before. So a 2.0 earthquake is 10 times stronger than a 1.0 earthquake. So it increases in magnitude quite a bit between each number. If you're looking at the Richter scale, just keep in mind that an 8.0 earthquake is going to be 100 times worse than a 6.0 because it's two jumps up on the Richter scale, so it's 10 times for each. So it is going to be 100 times worse of an earthquake than the 8.0s than a 6.0. Alrighty, that is plate tectonics. Thank you for watching. See you in the next video.